be the problem.
You should do this more often. Get the broken ones.
It's terrible. No, it's awful because like you put your hand on your paper to write, and it's going to be all over your arm. And we found out on the quiz, like if you started at the top of the quiz and worked with number 1, like your hand is on the paper. So then like the bottom 2 problems were gone because their arm had just wiped them away. And so the kids were trying to write like they were writing like this on the quiz, like this is their arm up, and it wasn't good. So finally I said, let's just get another sheet of paper out and do this. But could be why the copier just stopped working at some point after I made all these copies. But it's back working today. Because I already wasted all that paper once, and it's fine. I didn't actually realize that was the problem until second hour. Like, I passed out the papers in second hour, and then we threw them away. Some of them kept them, but most people threw it away. And I just said, I'm done. I'm throwing it away. What do you have to solve for in this one first? B. You have to solve for the other one that goes with this. That's why you can tell if you can use law of signs right away. If you have 2 that go together, and then the other one you can solve for sine of B over B equals sine of A over A. Say my class today was making fun of you because they said, "Why do you always laugh after your joke like that on the announcements?" They don't like it. But it's like a weird laugh. It's like not a real laugh. It's like a and they said, "Why does he always do that?" At least we're listening, because we can't always say that we're doing that. You should.
It's because the crop is getting smaller.
You should start telling math jokes.
I forgot to write down joke I was supposed to. Initiative from the student body. Well, let me write this down.
I can give you some trig jokes. What did he say? What was that, Sam?
I'm not going to say it.
He already said it once.
Say it again.
When I see that this is smaller than 1, I know that I'm going to have to check for 2 because this is angle side sides. So it again becomes pretty repetitive. If you did your homework last night, it becomes pretty repetitive. I'm not going to lie, I always do your homework. And I quit on the homework on this one. Like on my paper. I did up to 18 and I was like, I'm over this. I know how to do all signs. I'm not doing it anymore. I didn't do the rest. But I don't have to take a test on it. So, yes. And I don't get points for doing it. If I was getting, you're getting a grade for it. But I was like, I'm over this law of signs.
You want to hear that?
Is it inappropriate?
No, it's actually pretty good. Why does Waldo wear stripes?
Why?
Because he doesn't want to slide.
That's pretty good. That's pretty good. So, how did I get this? I did inverse sine on my calculator and got 50.8. How did I get this one? I know in quadrant 2 there's another angle that's the same reference angle as 50.8. So I don't even draw this anymore because I know every time I'm just going to subtract from 180. You with me to there? So then the next part is, how do you know if we do 2 triangles or just 1 triangle? Is look at the angle that they give you. That's A, that's B. We need to find C because we know the angles in a triangle add up to 180. So I can take 180 minus 32.5 minus 50.8, and I get 96.7 degrees. And I'm going to do the same thing over here, but if for some reason I would get a negative angle, or if those 2 together add up to 180 that you can already see, that's when you would throw that one out. But I think this one works because I like to make you do the ones that work. Because I'm mean like that. You get 18.3 degrees. Yes?
Remember after the Friday Mr. Main question?
You need to talk to Mr. Burgess about that, because he's the one that took it over, and then it's...
Last semester, Mr. Moore, I'm Mr. Lopez, so you should get some donuts. I have not seen any donuts.
You need to talk to Mr. Burgess is in charge, and Mr. Burgess has dropped the ball on the Mr. Brain Buster.
We still call it yes mark.
It never happens anymore.
We won twice. We won both my meetings.
We never got our donuts.
Mr. Burgess is in charge, kids.
How about we just, how about,
Let's call out Mr. Burgess right now on the recording.
Mr. Burgess for our donut.
What else we're missing here? We're missing side C. And again, this is very much on your calculator. What I do is I write out the proportion and then I just do it on my calculator. So if I was doing this, you can use B if you want. I tend to always use the two that they gave me to begin with. So I would say C over the sine of 96.7 degrees equals A, which is 5.2, over the sine of 32.5 degrees. That's going to be little c on this side. And then little c over here is the same thing, except where instead of using 96.7 degrees, we're going to use 18.3 degrees and get c over the sine of 18.3 degrees equals 5.2 over the sine of 32.5 degrees. And hopefully you type it in your calculator correctly, because it just really stinks to miss a problem on a test because you didn't type something in correctly.
Or have it in the wrong mode.
Have it in the wrong mode. Hopefully they're all in degree mode at this point, since that's what we're doing right now.
So does it add up to 90?
Does what add up to 90?
The 50.8, 32.5.
No, because it's not a right triangle. When you add all three of them up, they should add up to 180. Right? This one's kind of close, but no, because this is 96.7. No, they don't add up to 90. In a right triangle, the two acute angles will add up to 90 because the other one's 90. But in a oblique triangle, they won't. So the only time the other two angles will add up to 90 is if you have a 90-degree angle. I got 9.6. This one should be smaller than 9.6 since the angle's smaller. In second hour, they called me out and said, "Don't you have all these worked out? Why do you retype them in your calculator all the time?" But I can't help myself. I like to type in my calculator thinking that you're typing them in your calculator, but most of you are just sitting there waiting for me to type the answers, so.
I'm not kidding.
Oh, but I draw a calculator. Oh, wait.
Yeah.
2.5, like you wrote 35.2. Usually I say round to the nearest tenth. Why did I put 2 on here? Because it just bothers me to write 3.0 because it's not exactly 3.0, but it's okay if you did. I just can't help myself. So that's exactly what we did yesterday, so hopefully you're feeling pretty good about that. Or annoyed at this point that you're having to do the same thing again. Yes.
I'd be curious at this, but when do you know when you need to do two?
Anytime that you draw the picture and you have two sides and the angle's right, like not in between it. Okay, so this is angle side side. That's how you know to do it. If you weren't sure, anytime that you do inverse sine, you could check. Even if you're doing it extra times that you don't need to. But anytime that you're taking inverse sine, that's when you have to check to see if there's two triangles. Because that's when you have the option that two things can happen. Okay? I think that might be the only one. Because if we just talked about it, if the angle's in between here, you can't even do it law of sines. So that's not going to work. The angle's up here, that's still angle side side. So I think anytime that you're taking inverse sine, you should be checking for two triangles. Okay? So like on some of them, I don't know, what other ones did you have to do? Like number six, you don't do inverse sine, it's angle, angle, side, and so you didn't have to do inverse sine, so there can't be two triangles. But on number nine, I believe, is angle, side, side, which means you should have been checking on number 9 to see if there were two triangles, because you're doing inverse sine. Does that make sense? So you can either think about the ratio of sides, like angle, side, side, or you can just think about, if I'm taking the inverse, there's always two options. Does that help, maybe? Okay. I printed your notes out because the next ones are story problems. You don't have to write out this entire thing, but you need to at least label the picture or write out the important information. Forest Ranger Chris is at Ranger Station A, which I'm calling this Ranger Station A. He sights a fire in the direction 32 degrees east of north. We'll talk about what that means in a minute. And then Ranger Rick is over here at Ranger Station B, and he sights the same fire on a line 48 degrees west of north. I want to find the distance from each ranger station to the fire. We want to know who's closer to the fire. But by the time they figure this out, they probably could have both been at the fire. But
Well, that's their line.
and then that's my fire up there. I didn't want to draw that, but, you know. So I'll be quiet a minute so you can get this all figured out. Also important to know that Station A is 10 miles from Station B. I think I forgot to write that in here one time, which is why it's in red, because we didn't have enough information. Which means I think, as you're labeling your picture, you could say that this is 10 miles. Or sign little fire. That's what I did. I am. Are we ready for this or not ready? Still writing. I don't know. I mean, I'm waiting for you so I can draw the picture. I just don't want to get ahead. But we're supposed to be finding how far each ranger station is from the fire. But I want to make sure, you might want to slow down for a second because this is the tricky part. 32 degrees east of north. What does that mean? Well, what people want to do is they want to just plug in 32 here. But that's not correct. If this is my fire, and I know my fire is this direction, then I could say I know north is this way, right? The second hour they were trying to argue with me, what if north was down here, depending on where you were, and I'm okay with that, but then that means my fire would be down here, so. But if this is north, 32 degrees east of north, which way is east if this is north? This way. 32 degrees east of north means that this is 32 degrees.
So you would have to find the sum.
So that means this whole thing is 90, so you can subtract 90 minus 32 and get what, 58 degrees? So 58 degrees is really what we're doing, and that's, I've never spoken that way in my life, 32 degrees east to north, but apparently rangers talk like that. And people that drive ships, what are those people called? Sailors talk like that.
Wow, that's like kindergarten stuff.
And Ranger Rick over here, he's at Ranger Station B, and he sights the same fire 48 degrees west of north, and this is north, that means this is west. So this is 48 degrees, which I think makes this 42 degrees. So just be careful on that. The easy mistake to make is just to plug in 32 and 48, and it's not going to get you the right answer.
Well, it gets you close.
Not close enough. Erase this now, so I can draw this. I want to know how far they are, which means I believe I'm looking for little a and little b. I'm missing the angle here, the fire angle. Can I find the fire angle? Just add those up and subtract from 180, and that would be, I think it's 80, because that's 100, isn't it? Yeah. We're going to use wall signs. This is not a right triangle. We have to use 8 degrees and 10 miles, because it's the only one we know, and we actually got to do this twice, right? We got to find A and we have to find B. So I think I could say B over the sine of B, which is 42 degrees, equals 10 over the sine of And I could do the same thing for A over the sine of 58 degrees equals 10 over the sine of 80 degrees. I got B to equal 6.8, and very oddly, I got A to equal 8.6. You with me on that? I didn't type my calculator this time, I just copied from my answer. But be careful answering the question. It says, find the distance from each ranger station to the fire. Little b is really the distance from which ranger station? It's really the distance from A to the fire. So 6.8 miles to station A, or you could say to Ranger Chris. And A is really the distance from Ranger Station B, so 8.6 miles to station B, or to Ranger Rick. So if they asked you which was closer, we would say Ranger Chris is closer.
But they can just both go.
They could just both go, right? So they wouldn't just wait around seeing who's closer. There you go. Letting the force burn down. Questions on that?
There's a down.
Now this one says two observers are 600 feet apart on opposite sides of a flagpole. Which again, I printed this out for you so you can have this lovely flagpole. But the angles of elevation from the observers to the top of the pole are 19 degrees and 21 degrees. Find the height of the flagpole. The big thing I want to point out about this one is just because they're 600 feet apart, does it say anywhere that they're each 300 on each side? No. And actually, we could say for sure they're not 300 on each side, because if their angles of elevation are not the same angle, then they're not the same distance away either, because those angles would have to be the same if they're the same distance away. So just don't assume that it's directly half 300 and 300. So again, sorry, I'll be quiet as you're sketching down what you need to sketch down. I do know. But sometimes in proofs we do assume. So.
Yeah, which is bad.
This guy looks like he's running over here. I don't even know how that happened, but
He's excited.
he's like, woohoo, I love flagpoles.
No, he likes it.
So I know that this entire distance is 600 feet. And remember, angle of elevation is the angle from, we're going to say from the ground. Technically, it should be from his eyesight, but we're not worrying about how tall he is. So we're just going to say from here to here. And it doesn't matter which one you call 19 and which one you call 21. I'm just going to say this is 19, and then from this side, this is 21 degrees. We are assuming that the flagpole is a right angle, because flagpoles should be set up as a right angle, right? Like buildings, talk about a building, they always assume that's a right angle as well. Unless you're Leaning Tower, Pisa. So in second hour they said, oh, we can just use right triangle stuff, which you want to, but you don't have enough information yet, because all you know is this whole thing is 600, which means I think we need to use this whole angle up here. Like I think we're going to use this big giant triangle to begin with, and then maybe we're actually trying to find the height of this. So at some point we're going to have to break this down more. Can I find what this entire angle is right here? Because if this is 19 and this is 21, that's 140, because that's 40 minus 180, means that angle up there is 140 degrees. What are you going to have to find before you can find the height? You got to find one of these sides, because we don't have enough information to find the height yet. So again, it's kind of like a two-step problem. Does it matter which side we find? No, as long as you do it correctly. So you tell me, do you want to work with 19 degrees or 21 degrees? 21 degrees works. 19 degrees works. If I want to use 21 degrees, that means I'm going to solve for this side. Call it something besides H. H is what we're looking for. I think I just called it A. Call it X. You can call it smiley face if you want. And I can use law of sines and say that A over the sine of 21 degrees equals 600 over the sine of 140 degrees. So I'm just using this big giant triangle there. Anyone have a question of where I'm getting that? If you use 19 degrees, that's what we did in the second hour. Guess what? We're still going to get the right answer. We're just going to get the other side of the triangle. 600 divided by sine of 140 times sine of 21. Not sine of tangent. I got A to equal 334.51. So this is 334.51. What else could we do? There's more than one way to do this, but to me, the easiest thing to do is now, what if I just work with this right triangle here? If I know this side, and I know this angle, and I want this side, can I just do some good old SOHCAHTOA here? Some people said we should do Pythagorean theorem, but we don't know what this is. We don't know that this is 300, so we'd have to do more work to get this. I think the smart thing to do would say, this is opposite, this is hypotenuse. So could I say the sine of 19 degrees has to equal h over 334.51? Right triangles, we can use this. Which means I'm going to take the sine of 19 degrees and multiply by 334.51. And I get that the height of that flagpole is 108.9. I like that problem because it's like a double step problem. And who doesn't want to measure how tall a flagpole is with their buddy? Yeah. What? What was this about? Oh, okay. I'm with you. You like to go out and measure how tall flagpoles are. Okay, that's it. This is 5-5 day 2, 38, 39, 40, 44, 45, 51. We only have one more day of new material, which would be Monday's notes will be 5-6. That's all cosines. Then I think maybe I have a worksheet. I have a review day, and I believe we're going to take this test over Chapter 5 Thursday and Friday of next week, which means all of your Chapter 5 homework is going to be due next week. So I hope that you're caught up, and if you're not, you should start trying to catch up. We'll go over this on Monday. We'll do the last day of notes, and then we'll finally get through Chapter 5. So.
Then we're doing other stuff, right?
Then we're doing Chapter 6.